In how many ways can two candidates for public office be chosen from a group of three? If we interpret this as a permutation problem, which is incorrect, we would calculate the number of committees as the permutation of three objects taken two at a time. And the way we would calculate that is we would do 3 factorial divided by 3 minus 2 factorial, which is equal to 6. So what you might ask yourself is, what exactly is this calculating? Well, let's take a look. If we refer to our candidates as candidate A, B, and C, from that group of three, we're taking two at a time. So we could have AB, BA, AC, CA, BC, and CB. Notice that for every pair of letters I take here, there is exactly the reverse order for that pair of letters. So for BC, there's also CB. But if all I'm doing is selecting candidates for public office, picking BC and CB is exactly the same thing, because the two candidates aren't like president and vice president. There isn't a pecking order here. So all we're talking about is taking two candidates. What we really should be doing is looking at AB, AC, and BC, where the order doesn't make a bit of difference to us because we think of AB as the same as BA, AC is the same as CA, and BC is the same as CB. So we really have twice as many things listed out here for our permutations as we want. And the reason for that is because every time we pick BC, there's another CB that you count when you do permutations. That's what's leading us to have twice as many things as we actually need. So we need to get rid of that and just count the things that you see here. In other words, how many ways are there to choose 2 letters at a time where we disregard the order? So the correct number of ways must disregard the number of ways to rearrange the candidate selected. So when we pick 2 things, there's 2 factorial ways to rearrange those 2 things. And so what we'll do is we'll take the number of permutations and divide it by 2 factorial. This is called a combination. Combinations are very, very similar to permutations, but the major difference is the order within the group of things you pick does not make a difference. And that's what we call a combination. So to find the combination of 3 objects taken 2 at a time, we can take the permutation of 3 objects taken 2 at a time and then divide by 2 factorial, which is the number of ways to rearrange those 2 objects. And this will give us the 3 things that we've listed out here below. So combinations differ from permutations with respect to order. When we talk about P of n comma r, this denotes the number of ways to order r objects chosen from a total of n objects. When we talk about C of n comma r, this denotes the number of ways to choose r objects from a total of n objects. In other words, when we just choose them, the order within the things we choose don't make a difference. When we order the things, then order definitely makes a difference. So in general, the way to calculate a combination of n objects taken r at a time is to calculate out the permutation of n objects taken r at a time, and then divide out the number of ways that you can rearrange those r objects, which is r factorial ways. So if we work this out, we actually can get a simpler formula. So if C of n comma r, the number of combinations of n objects taken r at a time, denotes the number of combinations, then C of n comma r is simply n factorial divided by r factorial times the quantity n minus r factorial. The n factorial over n minus r factorial is the permutations that we've already talked about. The r factorial on the bottom divides out all the possible rearrangings. So let's go ahead and calculate the combination of 5 objects taken 3 at a time. So this means that n is 5 and r is 3. And if we put it into the formula above, we get 5 factorial divided by 3 factorial times 5 minus 3 factorial. 5 minus 3 is just 2. So we see 5 factorial divided by 3 factorial times 2 factorial. If we work out all of these factorials and then do the division, we get 10. Now your TI-83 calculator has a function built into it which will actually calculate this for you. So to calculate on the TI-83, what you would do is from your home screen you'd press 5 because that's the things you're choosing from. You'd hit the Math button, then use your arrow keys to navigate to PRB. Choose the third one. That'll say NCR. So NPR was permutations, NCR is combinations. Hit Enter. That will paste it back to your home screen. Then you'll put in 3, which is the R, and then enter again to actually do that calculation. So if we do the combination of 10 objects taken 6 at a time, we'll get 10 factorial divided by 6 factorial times 10 minus 6, all factorial. In other words, this will give us 10 factorial over 6 factorial, 4 factorial. Working out those factorials on our calculator will give us 210. What you're going to notice is when you do combinations, if you're picking 3 for the number of objects, a 3 factorial appears in the bottom, but so does 2 factorial, and 3 plus 2 adds up to 5, which is on top. Down here, the 6 plus 4 adds up to 10. So you can kind of use this as a bit of an internal check when you're actually writing these things down. But for most of you, you'll be calculating these combinations by using your calculator. So in this case, we would type in 10, the Math button, go to the PRB menu, select NCR, which is the third choice, press Enter again, and then 6. Pressing Enter one more time will go ahead and calculate out this 210 that you see here.